We will investigate a case study in order to explain the steps better. The task is to test the design controller to determine if the target vehicle velocity is achieved. 3 components will be joined: a battery, a permanent magnet synchronous machine, and a longitudinal vehicle dynamics model, all of them having level 1 complexity. Here we have all 3 components opened in AIM-SIM, ready to be joined into one system. Now we have to create a new blank AIM-SIM model. For this we will go to File, New, Empty System, we click on OK, and then we save it into a desired directory. And the model is ready to contain the parts we will add to it. In order to join the parts together, we have to select them, copy them, and simply paste them into the blank model. We then have to decide what do we do with the variables imported. In this case, we have selected to make global variables out of the parameters. We do the same process for the battery, the motor, and the body. A little hint is always labeling the input and outputs of the components. This way later it will be easier for us to connect the parts together. As we can see, after all the parts are brought into the new model, it is clear what ports have to be joined together. And after the connections are done, we are ready to go to the next step. After the connections have been made and checked, we proceed with the simulation. When the compilation ends, we adjust the run parameters. In this case, we need the time of 190 seconds to fully display the new European driving cycle. After the simulation is finished, we compare the speed requested in the beginning of the control path with the speed output from the system path. This is done by drag and dropping the values onto the main screen. We can zoom into the graph to see how accurate we have been. As we can see, the requested speed have been achieved. In conclusion, the predefined PANDA components facilitate the easy reuse of models, reduce the development time, and they offer flexibility in test case modeling.